Welcome to this question. In this question, we're going to have a look at an analysis task. So the question states, in a beachside town, there is a tidal river where h is the height in meters of the river according to the rule of this. So t is the time after 2 a.m. on a Sunday. So that's going to be quite important because that gives you the reference of the time. Now, question A, state the period and the amplitude of the rule for h. So the period, 2 pi over n. Now, in this situation, n is equal to pi on 6. And that is just obtained from the number in front of our t value, or x. Okay? So what we need to do to work out the period is, the period is just going to be 2 pi over pi on 6. And that can be written as 2 pi divided by pi on 6, which is the equivalent of 2 pi times by 6 over pi. Now that and that cancels, and you get 12. So the period is actually, in this situation, it's equal to 12, and it's equal to 12 hours, because the time is measured in hours. Okay, it says it here, the time in hours after 2 a.m. on a Sunday. So that's the period. So that would give you your 1 mark. Now, the next thing you have to do is you have to state the amplitude. So the amplitude is the number in front of your trigonometric function, which in this case is 2. So the amplitude is equal to 2. Now, I put a modulus sign in front of it because you always have to make, even when you have a negative answer in front of your trigonometric ratio, you're still going to have to give it as a positive answer, and it's in 2 meters because that's what the height is measured in. It's measured in meters. So that's the amplitude. Okay, so this will be your second mark, your amplitude of 2 meters. Okay, so that's the first question A. Question B, state the maximum and minimum depths of the river. Now, to work out your maximum and to work out your minimum, you need to use your amplitude. So the maximum is taking your amplitude as a positive number. Well, remember that in a trigonometric function, if you didn't have this plus 3 for now, we know that the maximum would be 2 and the minimum would be minus 2. And the graph would probably be going something like this, right? So you know from the number in front that that number can actually be a positive 2 or a minimum of negative 2. Now, this plus 3 needs to be added to the maximum and also needs to be added to the minimum, because that's the whole graph will be essentially translated up by 3 units. So the maximum value will just be 5, and the minimum value will be 3 minus 2, which is 1. So these two are important, so that's meters, and so is that. And yeah, so we've just calculated the maximum and minimum values. Now, let's have a look at question C. So question C is sketching the graph of H for the next 24 hours from 2 a.m. on Sunday, showing all the relevant information. So what we have already figured out is we've already figured out what the amplitude is. So we know that the amplitude is 2. We also know how far up this graph has been shifted. So it starts off from 3 because that's the plus 3 that we worked with before. And we know that the maximum, so we'll write this should be in terms of height. So the maximum should be 3. Sorry, the middle value is 3. The maximum should be 5. And the minimum value down here should be 1. So now what we're going to do is we already know that the period is equal to 12 hours. So that's one rotation. So probably around here we'll have 12 hours, and we know that the graph's going to have one period by 12 hours. Now let's have a look at the actual formula. So the formula was, if we look back at what the formula was, it was positive. It was a positive sine graph. Okay. So what we know is that this sine graph, it will begin from 3 and it will actually move its way up. Now halfway to 12 is going to be 6. So we'll put 6 there. And half of 6 is going to give us 3. So we have to then halve this point here, which gives us 9. Okay, so we've got all of our information. Now what the graph will do is it will actually become a maximum at 3 and a minimum at 9. So maximum being at 3 being right up there, and minimum of 9 being down here. So the sine graph is going to be doing something like this. So it's going to go up, it's going to go back down, and then after that it hits the minimum and then it goes back up. So that's part of it. Now we have to draw the next part of the graph. So it seems like every 3 blocks we have an extra 3 added. So that's going to be 15, 3 blocks. So 18 and then 3. We've got 20, 21, and then finally 24. So we know that at 15 we're going to have our maximum again. Then back at 18 we're going to have our 3 meters, and at 21 we're going to have our minimum, and then we're going to go up to our middle value. So this will become extended. Okay, so that is our graph. So we can label, and we should label these important points. So 0 and 3, that is going to be 3 and 5, and you can just go and label these. So 6 and 3, 9 and 1, so forth. So this question's worth 2 marks. We've shown all the relevant information. We've drawn it to scale, so that should be all we need to do. And then the final part of this example, when the water first drops to 1.4 meters, Andrew climbs a tree that is in the river. Andrew cannot swim very well, and he must get down from the tree when the water rises to 1.4 meters again, or he'll be trapped in the tree. For how long to the nearest minute does Andrew have to play in the tree? Okay. So what we need to do is we need to check where 1.4 is. So this will be 2, 1.4 will be about here. I'm just going to go along. This is the first time that the river gets below 1.4, and this is when it starts getting higher than 1.4. And of course here and here are again regions of below and above 1.4. So this is where the height is equal to 1.4 meters. Now the question asks you, so when the water level first drops to 1.4, so that's probably around this time here, Andrew climbs a tree. He cannot swim well and knows that he must get down from the tree when the water rises to 1.4 meters again, which is there. and it says how long can Andrew stay in the tree. So you need to find where this time is, followed by time 2. So what we know in this question is we know that the height is equal to 1.4 meters. And what we can also use is the formula. So it's 2 sine I believe it's this formula. Let me just double check it. 2 sine pi on 60 plus 3. Perfect. So what we're going to do is we will substitute in the height. We know what the height is. And we move the 3 over to the other side. So it's going to be 1.4 take 3. That will give us negative 1.6 divided all by 2. Okay, so now that we've got this information, we can just write sine of pi on 6t equals to negative 0.8. Okay, and then we have to use our unit circle to identify where negative 0.8 is. So negative 0.8 is that at this location. And so there are two solutions, this one and this one. So it is important to obtain our base angle. So by obtaining our base angle, we can actually work out now the angles here. So we have to obtain our base angle, we'll just go sine inverse of 0.8. It's not important to go negative 0.8 because we've already identified where our solutions are negative. Now we know that sine inverse of 0.8 generates a value of 0.9272. Now this has to be in radians, and you do need your calculator to work that out. It's not an exact value. Okay, so that means that this angle here is 0.9272, and this angle here is 0.9272. Now, to work out the actual answer, first of all, we'll probably need to obtain the actual angle from the reference axis. So what I mean by that is we need to obtain, this is our reference axis here, and we need to obtain how many degrees how many radians we need to get to that point, and then we need to determine how many radians is required to go all the way around up to that point there to the second solution. Okay, so we already know the radians, so anything in the third quadrant, which is where this solution here is, we take, so we go pi over 6t, and we go pi plus the base angle, so that's plus 0.9272. And then this is in the fourth quadrant, and so any solution in the fourth quadrant, it requires you to go 2 pi, take away. Okay, and so we're going to just obtain our answers for these two. So that adds to, I just calculate it right now. So it adds to 4.0689, and this part here, 2 times pi, just working it out in your calculator, minus 0.927. It's important to use as accurate answer as you can. So just use your CAS calculator to work this out. You'll get a value of 5.33589, and then we need to multiply both sides by the reciprocal of 6 over pi. So each of these values here, we need to multiply them by 6 over pi, and that's essentially to get rid of the pi on 6 and to simply obtain the answer. So when you times it by the reciprocal, all of these will cancel. You'll get t equals 2. So we have to times 6 over pi by 4.068, and I'll just calculate that right now. 6 divided by pi. Okay, so that gives you 7.71771, and I may just keep it in 2 decimal places. It does say to the nearest minute, so we will convert these into minutes soon, so I might have a more accurate answer, because these currently are in hours. And then this multiplied by that value there, I'll just calculate it right now, so 5.35589. So that gives us 10.229 hours. Okay, so these are the times. These are both of the times that we identified on our graph a moment ago. The smaller one being time 1, the larger one being time 2. So if we look at our graph here, so that time 1 indicated here is 7.71, and this is the 10.229. Okay, so this is the amount of time that Andrew can actually spend on the actual tree, because that's still where the river is below 1.4 meters. So the question, be very careful with what the question wants you to find. The question wants you to find how long to the nearest minute does Andrew have to play in the tree. So now you have to find the change in time. So to find the change in time, you have to take the maximum time and subtract it from the minimum time. Okay, so this will give you the length in which Andrew can actually spend in the tree. So we're just going to go take the difference between the two, and we get an answer of 2.45799 hours. Now it wants you to express this into the nearest minute. So therefore, we know that it's 2 hours, 2 full hours, and then this part here is a fraction of an hour. So what we will need to do is, we know that there are 60 minutes in 1 hour, and to work out the minutes, we have to times by 0.45799. Okay, so we are going to just eliminate the 2 from that and then times it by 60. So we get, that answer gives us 27.479 minutes, which if you want to get it to the nearest minute, I would just say 2 hours and 27 minutes. It hasn't really reached half a minute yet, so you have to round down. So that's the entire question. You have to be very careful about what the question wants you to find, and because if you just find the 2 times, you're not going to get the full marks for the question. This question should probably be worth also 3 marks instead of 2 marks. I wouldn't really allocate it 2 marks because there's quite a lot of steps involved. and you do have to show some workings, but that's essentially how you do the question.